Today. So I got a little bit of an update around. So the contract job, I got the scoring hooked up. I'm just tying up some loose ends there. It's the last mile. It seems to take forever, but it's coming along nicely. But it got me thinking about something, and it's something that I made the change for on that project, and now I'm going to make it for eGloo. And I wanted to talk about sort of the design decision there and sort of talk about some evolution in my thinking over the years around database migrations and database schema structure. So there's actually a couple schools of thought on all this, right? Like depending upon which direction you come from, right? There tends to be, like, among the developer community, this idea of putting your SQL into your application layer. So whether that be Python or Java or JavaScript or Go, any of these languages, you sort of would store your SQL there, or you would work with an ORM, and that ORM would be a third-party package or framework that would handle the migrations for you, and it would do it in sort of an object-oriented way that would allow for how developers normally think to apply more to a relational database. And there's a lot of limitations there that over the years I haven't liked. So principally among them is that when you work with a relational database, there's a lot of power and functionality there, particularly if working with one like Postgres, which is my personal choice, that an ORM really kind of doesn't fully expose to you. Or at the very least, when you're working in that capacity, you're not getting, let's just say, you're not really driving it with full capacity. Now, a lot of people don't like working with relational databases because of the requirement that you need to actually strictly type your schema. They feel it makes development go slower. It's easier for them to work on the application layer side and either have it handled by an ORM that talks to a relational database and handles it for them, or working with a database that's NoSQL, like Mongo. And then if they need any kind of strict validation for the data, they would incorporate a layer like Mongoose to wrap the calls to the driver to make sure that things conform to almost an ORM, but not quite an ORM. In that case, it's not an ORM; it's just an object model, but same concept, right? You're trying to make development more conceptually friendly to the way that application development works. But the trade-off there is that a schema really does give you a lot of benefits, right? First of all, it strictly types your data, right? That's the most obvious. So only the kind of data that is typed for a particular column can go into that column. But it also allows you to do things like, say, this column can't be null. But you can also do like triggers on a column if you have a certain power that like a Postgres will give you. You can have row level security. You can have triggers on a table. You can also do what's called materialized views. So you can have a fully normalized relational database schema, but then you can create views that actually denormalize it, and you can query them as if those are actual tables. And with Postgres triggers, you can actually make it work so that you can interact with that view as if it were a table, and it'll write down to those individual normalized structures, right? So you get the power of having a fully normalized, clean, typed database model without, giving up any of the comfort of working with a more denormalized view, right? So you can get a lot of benefits by working directly on the database layer, and that's just working on the schema side. Triggers can be used for having slowly for slow moving dimensions, or having a time dimension, or some sort of audits table. Automatically. You don't even need to write the code for it anywhere else. You just apply a trigger to a table. Whenever that table is modified, it writes to an audit table that is a sibling of that primary table. Referential integrity, making sure that your keys are constrained to an actual existing reference in another table. That's something that like Mongo doesn't really provide. transaction support, having rollbacks if a series of things goes wrong, or the thing that I've been really using more recently and that I want to talk about it, stored procedures and user functions. So an actual way of putting code into the database as if it's more of a microservice. And that's kind of how I've been thinking about this recently, and what I want to talk about, how I've been designing these things recently. So, some of the other trade-offs with ORMs is you can't really do complex querying easily, and if you do, it usually means circumventing the ORM entirely, and then you're writing SQL directly in your application layer. Or, if you're doing any kind of complex migration, you end up writing SQL anyway. Most migration layers can't handle a truly complex migration. What is a complex migration? It's usually something where a type changes, or a cell is split, let's say, or just anything more rudimentary than a rename or a table add or a column add or something along those lines. You generally are looking at getting in the weeds a little bit, right? So from my point of view, application developers, if you're building a site that's essentially like, all right, let's say it's a mom and pop, branded pet food store, and it makes exactly that one brand of pet food. No SKUs more than that. Maybe it's 5 SKUs. Maybe they've been in business 20 years. Maybe that's all they do, right? That's all they do. Then that's fine. You can probably get away with an ORM in that case, almost assuredly. But if you are talking about anything that's a living, document model, a site that is going to be developed for years, where there's going to be additional features, where you have to get to scalability issues around sharding and replication, very quickly you're going to realize that an ORM is not really helping you as much as you might initially think it is. And then the other side to it is, an ORM is much more helpful in a language like Python or PHP than it is in a language like Go. And the reason for that, I've realized, is that with Go, we can actually store, there's definitely libraries out there, or Go packages, that'll allow you to more cleanly map into a structure, and I do think that's valid. But really, fundamentally, Go is not a language that you want to try to write dynamic SQL querying in. I just don't feel that that's its biggest selling point or its strong suit. You're going to be handicapped a little bit there, trying to make that work. So I'm a big believer in a few things. First is separation of concerns, letting each piece of the technology stack be its best without hampering anything else in that stack. And really, I'm a continual learner. So if there was a period of time where I was not very strong with relational databases or querying in relational databases or schema definitions, and frankly, it was a little overwhelming. But I worked through that, and I really, really pushed myself to get good at it. And the benefits are immense. Like, there's no database that you can show me that I can't sit down and start querying pretty much immediately and understanding like what it's doing. And I think that's, that's a benefit. It's a tool in your tool belt, and you want to make sure that it's a very well maintained tool, right? So, you got to know what a window function is. You got to know how to do, date intervals, how to do, what is a coalesce? Why do you need a coalesce? How do you do, different kinds of joins? What is a left join versus an inner join? What are some group by functions? Things along those lines. How do I optimize a subselect? I think these are all really important things to get good at, not because it's just it's bragging rights or anything like that, because in a lot of ways it's the least visible part of the stack, but to be really, really comfortable with your application means being comfortable with your data, and that means being comfortable with your data in the native storage format in which it's in. right? So I really think it's to everybody's benefit to get good at SQL queries and DDL, schema structures, all that. So now that always gets people to the question of, well, if you're not using an ORM, how are you doing database migrations? Very good question, and that's what you see here with this tool I've got up. It's called Sqitch. I love Sqitch. So Sqitch is it's a Perl package, but you don't need to know any Perl. It doesn't do a whole lot of, it's self-contained. It's just another command line tool. You install it with Homebrew. There's nothing, complicated or fancy about it. If you're on Mac OS like I am, it's literally a brew tap and then a brew install with the particular DB supports you want. They have Windows, Ubuntu Debian, Red Hat, Docker, or Source from cpan. And I mean, this is a really well documented project, really great. They have a community. Documentation's really good. And so, they support all these database engines. So they've got Postgres, they got SQLite, MySQL, Firebird, Exasol, Oracle, Snowflake, Vertica. There's presentations here if you want to watch. And then they also recommend test-driven development using PGTap, which I have to actually add into my stack. But these are folks who actually, I don't know if it's one guy or if it is folks, but anyway. But yeah, they know what they're doing. Like if you really want to have top grade database structure and support and tooling, I would highly recommend Sqitch. So, if you get going with it in the tutorial, it's a tool that very much tries to mirror the workflow of Git. And so they recommend first starting a Git repository. Not that you need it to work with Sqitch, but just best practices. Let's assume you're working in a version Git repository. And so you have that, and in this case, I'm inside of eGloo, right? Now, I want to actually make a new Sqitch project inside of eGloo for all of eGloo's database needs. So I am going to do Sqitch init with engine Postgres, and the name of the Sqitch project is going to be eGloo. And boom. So it created 3 folders: deploy, revert, and verify, and a Sqitch conf and a Sqitch plan. Sqitch conf is what it sounds like. It's just the configuration for Sqitch for this project. So it says the core engine is Postgres. If you want to have specific engine configurations, they go here. There's a default plan file, but you can overwrite it. In this case, we're sticking with the default, so there's no need to uncomment this. So what is a Sqitch plan? A Sqitch plan is essentially a loose equivalent to the history in Git. And what I mean by that is, as you make a migration, each of those migration steps is recorded top to bottom in order of execution in your Sqitch plan. So if we look in the Sqitch plan right now, you will see that all it really has is the syntax version and the name of the project, which is eGloo. So there's not a lot going on there. But if I start to do Sqitch add, right, I can actually add a migration step. Now, the one thing to note here is that unlike Git, where the history is maintained in order for you, and you can go, forward and backward, git revert or git checkout, sort of however you want to. These are named migration steps. And so when you're looking in the folder, they're all stored in individual files as pure SQL, because it tries to be a native migration tool, which means that it's not running another language, it's not running its own DDL of any kind, it's not YAML or XML, there's no generated code. It is running exactly what you tell it to run at each stage of migration, up or down. So, and that's very powerful. That means you're getting exactly what you think you're getting because you wrote it. So I appreciate that. But it also means that organizing this to some degree falls on the user. And the way that I've done this, because you never want to get lost trying to figure out where you are in your source code, just looking around. So I have these, whenever I make a new migration step, I prepend it with 4 digits, starting with 0001. And each step I just increment this, so the next one would be 2, then the one after that would be 3. And that just keeps it in sorted alphanumerical order inside of that directory, either in the terminal or in the Finder. Just for convenience, I don't want to go in, figure out what step of the migration I'm in, and then copy, paste, hunt around for that. It's if you got like 200 migration steps, that is miserable. So make sure you do this part up front and right. Although just your OCD will thank me later if your OCD is anything like mine. So yeah, we add that. You get this same prompt, the same one that you normally get for either a git commit message or a merge. So I'm just going to do initial schema and then write quit. Now this created 3 files and it updated the Sqitch plan. And if we look at the Sqitch plan again, what we'll see here is this entry now, which is the same name as the one I provided, which is also the same name of the SQL files in each of those directories, which we'll get to in a second here. And so if I make another step, it'll just be the next line after this. It records the timestamp for when it was entered, who entered it, and then the comment associated with it. So you sort of have your history in here. And like I said, it just reads lexically. So that's cool. So what does this actually do, right? So deploy, revert, verify. This is your up and down and your verify stage. So when you deploy, it's real simple. And you can deploy to multiple targets, which I really appreciate. So in this case, I have a Sqitch deploy tlocal. If you don't configure your Postgres backend, it'll just try to do localhost, but you can actually target it. You can set up the actual connection details for each target. So I would have local and a prod, tend to, and I would create an SSL tunnel to prod or however that connection works. So, but the cool thing here is that you can actually deploy 2 multiple stages with the same migration step just by a command line flag toggle. Super powerful, very powerful. So. And the other cool thing is, let's say you deploy and it's totally hosed. You can do a revert. You can target your revert too, so it can be targeted to your local or your prod. And then you can tell it how far back to revert. Same kind of syntax you get with Git. So if you want to revert one from head in Git, it's that head caret 1 or head tilde 1, something along those lines. Here, this is what you do. It'll roll it right back. Now, all these changes, the migration history, the active journaled record of it, which is to say what has been migrated versus what is in the plan to migrate, that is maintained in Postgres in its own namespace, in its own table, just under Sqitch. You can go in there and you can inspect it. But all it really does is just say, this, these are the migrations that have been run. This is the information about the Sqitch plan and project. And it just basically records state for that database so that Sqitch knows, okay, we're at this state in the database, I need to run these additional plans. Or if I'm doing a revert, I'm reverting back and so on and so forth, right? So under the hood, it's pretty simple, but that simplicity is very well presented and packaged in a way that makes working on this super, super flexible and clean. So the deploy, if you actually open this up, right? So let's do, just do cat it here. Right now inside of this, it's just a comment for what this is, and then a begin and a commit, right? So we're in a transaction here. And just a note, add your DDLs here. So this is where you would do your create tables, your alter tables, your add constraints, your create indexes, create or replace functions, whatever it is. This is essentially your migrate step forward. And all it is simple DDL language in SQL. So if you can create a SQL table, you can use Sqitch, right? Very, very clean, and I like that. I like that a lot. And then Also, well, let's start with verify. Revert is pretty simple and straightforward, but verify is interesting. So verify is a way of saying, okay, I ran my DDL, but I want to make sure after that migration step ran, everything's okay. If everything's not okay, automatically trip the revert. And so if you have this verify stage, I think this is where a PG tap gets used. I haven't really leaned on this as much as I ought to have, and I'm making a point of doing that more. But this is essentially, I mean, this could be anything from, doing a select to make sure there's a particular value in there that you're expecting, or that the table schema is as you expected, whatever it is, right? This is your validation stage. This is making sure that the migration deploy took. And that's important because as Sqitch is really only a SQL runner with a plan file and a history of runs, it's not doing any of the validation for you, right? It's not, there's no built-in automated schema validation. Which is, there's good and bad to that. The bad is that there's, certainly, there's a tendency to laziness. I have that as much as anyone, where, it's just testing often gets forgotten. So if you're like me in that regard, just you have to be a little bit more vigilant, and that's the price you pay for the simplicity here. But the positive to it is that it means that your validation is not obfuscated from another tool that could potentially have a bug in it, or be broken, or need to be updated, or whatever have you. It's literally, if your validation here is SQL compliant, it runs and everything checks out, that's good. That's all you need. And that kind of makes sense. Like if you think about, you connect to a database, somebody asks you, do you have access? Well, that's a simple thing. You just load up a couple views or a couple tables, and then you do some couple queries. You try to do a join or two, and if everything works, yeah, you've got access. Your things are good. I mean, the same thing with did that table did those records go in? You do a select count after a certain created out date. Is the number going up? Okay, cool. So if you think about it in terms of how you manually verify data in a database, this verify stage makes a lot of sense. So I really like that. And then the revert stage. At this point, you shouldn't be surprised. It's also a blank transaction with DDL goes here comments. So, and all this is, it's exactly what you think it would be. It's your drop table. It's your drop cascades. Now, one little gotcha here. Sometimes I like to get a little cowboyish with Sqitch plans where I'll roll up and down, back and forth before I sort of solidify a migration stage and then deploy it against a production stage environment. And what you'll find is that sometimes you'll rename a table, but then you'll have a drop that applies to an old table that no longer exists. And my recommendation for that is just, or you get locked on a key constraint. So just try to be ahead of that. I mean, it'll blow up at you either way if you don't. So it'll make sure that you're reminded if you don't remind yourself. But the way around that is just doing drop table if exists, or drop function if exists, or if it's foreign keys, drop with a cascade on cascade deletes. So and that usually takes care of most of those issues. So yeah, and then what this allows, first of all, is you're starting to move away from having your database schema be something that is the responsibility of the application domain. And I think that's super critical, because the application is not the domain expert for a relational database. I don't care what language it is, or what framework, or how badass the application engineer, unless you're actually working with the most, the advanced functionality and really an expert in relational databases with Postgres, you're not exploiting that tool to its fullest capabilities. So this allows us that separation where, all right, we're letting the tool that can most effectively handle that job. And we're doing it in a way that has history, versioning, migrations, validations, reverts, a very familiar Git style interface for managing all of this. So far, all fantastic. The only other thing that I wanted to point out here was, so this fixes, I'd say, 60% of the problems that come from working with SQL in application code, in the sense of your DDL is now out of the picture. The other problem is, and you'll almost always see this, either it's an ORM or it's raw SQL. If it's an ORM, like, to some degree, like, if you want to use Sqitch for migrations, but then use an ORM or a slim ORM, like there's actually, I think it's SQLX on Golang. All it really does for Golang is, instead of having row scans into variables, it puts it into a cleaner struct. And that has a lot of advantages. I personally prefer that approach, right? But that's not really an ORM in the traditional sense. You're not defining the structure to then have it mirrored in the database. At that point, what you're doing is understanding what the database structure is, preparing your struct accordingly, and then just having a more flexible payload to push around as a singular variable, which it's just a matter of code and consolidation. But you're not going down the full rabbit hole of an ORM where it's writing queries for you per se. So there's that, but then you also, obviously, you can get into more complex ORMs, whether it be Laravel or there's so many, SQL Alchemy, I believe. Yeah. So, I mean, whatever ORM it's working with, and if it starts generating SQL for you, I get real hesitant about that. For a developer who doesn't know SQL, sure, that is removing a blocker that is absolutely impeding progress. The problem is, from my point of view, it's also giving a false sense of security about how much of the problem it solves for you. And what it's also doing is adding, if you're ever going to get to a certain degree of scale, it's adding potentially massive technical debt in two areas. One is that, this ORM and all of its, its pros and its cons, whatever warts it may have, whatever bugs it may have, those are now your bugs. You have to deal with them. And so if it's generating goofy SQL and it's a, very unclear how that SQL gets generated, and you've got to, subclass something, or do a direct injection of some kind, or do some sort of hook, at this point, what you're really doing is you're working around the ORM. And so I'm not a big fan. I know SQL. I'll write the SQL. I'm not scared of it. So, and that gets you to the other of the two choices that, I thought there were two choices, and now I've discovered a third, or I should say I haven't discovered, but I've arrived at and prefer now. So, but yeah, the second one is writing raw SQL in your application layer and executing it. The biggest problems I have with that are, one, syntax highlighting. Generally what you end up doing is writing SQL inside of a string constant with some input variable markers, $1, $2, and then when you actually execute it, you got to pass those variables in, and then you get a couple hundred lines of SQL inside of something that has a file extension other than .SQL, so your code editor is like, yeah, okay, that's just a string. So you don't get any SQL or syntax highlighting. You might get string mangling. There starts to become this temptation to do dynamic string creation, and I sort of feel like it sort of puts you down the path of wanting to treat SQL more dynamically than you maybe should. So I'm not a big fan of that approach anymore. I feel like it creates a lot of spaghetti code hidden inside of a string constants that it's just a nightmare. So where I've been moving to is creating stored procedures or user functions, really the difference is one returns a table and has transaction support, I believe. Actually, let me double check. I don't want to give you guys bad information. So Postgres stored procedure versus user function. Yeah, user-defined functions do not execute transactions. So, and by the way, I feel like if you don't know something, don't stick to your guns. Double check, or if you're unsure about something, I've got no embarrassment of letting you guys know. I don't have Google inside of my head. That's why Google is all available to us. So, but yeah. So the way that those work, right, is you can define PL/PG/SQL, which is sort of like procedural SQL, which is cool because you can do for loops, you can do if/else, you can do cases, a lot of control structures. You can define your return types and your input types. You can return table. You can do inserts or selects or updates or deletes. You can, it's really like a mini SQL Sqitch plan, right? And you can also write those functions and turn them into triggers. So you could have, let's say, a table that is user profile, and then you create a trigger that updates row entries on a user profile history table, and every time one of those values changes, a trigger fires a user function that you define that automatically goes and writes it in. So that makes a lot of sense if you're writing a lot of application logic, or business logic, I should say, inside of SQL and Postgres itself. But the other benefit to that is that it creates a single interface with a single set of inputs and a single response set in one line of code that you can then reference inside of your non-SQL application logic. In other words, rather than have, let's say you have a 300-line SQL query. It's a beast. It's got time dimensions. It's got multiple joins. It's referencing all kinds of things, right? It's big, and necessarily so. Can't whittle it down. So, do you really want that in some file that is .go or .py or .rb or .java? I don't. I don't want to go looking around and hunting through these files. I don't want to try to. I hate copying and pasting that code out, putting it into pgadmin4, replacing the $1 with an actual test variable. It's all just it's a mess. It doesn't allow for rapid development. But if you are just calling, let's say, my user function, select star from my user function, and then 3 parameters in, and then you get a response back, that doesn't change. It only changes if you add more inputs. But you can completely rewrite the entire function on the SQL side without ever having to recompile your Go binary or update your Python code or anything else, right? So it almost turns Postgres into a microservice with not really an RPC, but something that gives you a similar enough interface to that concept, right? You have a function inside of Postgres that you want executed and you want the response from. So I'm a big fan of that. You no longer are worried about your SQL syntax highlighting or having to store all this big, massive SQL spaghetti inside of a file that's not in that language. You don't have to copy and paste things around because you literally, if you want to play with it, just play with it right inside of Postgres. If you need to change it, you don't have to redeploy any of your application code. You just change it right there in the DB, and then if it takes, just turn it into a migration plan. And all it is a create or replace function. So that has been a huge productivity win for me. Helped me go a lot faster, and I highly recommend it to you all. And so, yeah, that's kind of this was originally going to be like another quick, hey, so I'm still working on this thing, but it's part of it is I want to make sure that I'm at least giving some useful information for each of these. So, and honestly, if I've noticed one major pain point in our industry, it's that not enough love and care is given to the data layer at the application layer side. It's really considered an afterthought. You know, there's plenty of times when I'll hear something along the lines of, this database is good enough, or we don't want this schema to be too complicated, it's going to be too hard to work with. These are all, in my view, complaints that are really rooted in just lack of familiarity. Because once you get familiar with SQL, it's just another tool. It's no different than hacking on any other language. It's more of a, it's definitely structurally different. You definitely think about it a little bit differently, but that's part of the fun. It's part of the challenge. And if you get really good at it, if you level up in your SQL game and your database game generally, it really unlocks a lot of possibilities for you. So I really recommend everybody, consider the approach that I'm proposing here. It's one that I'm working with now for one client and for eGloo. So I'll some examples will be going up in eGloo. People can look at and play with. But more generally, I mean, I would just challenge everybody to, there's that old saying: be the best you can be. Unless you can be Batman, then be Batman. I kind of view this as being the Batman of software engineering. If you can get really good at both the application layer and the data layer, in my world, you're Batman. So with that, hope this was helpful. Hope you enjoyed, and see you tomorrow.